Functions and graphs video, just some quick revision here on what a hyperbola looks like. Okay, to sketch y equals 1 on x, we have a hyperbola. It's got a few interesting features here. It's in the first quadrant and the third quadrant, and this one goes through the point 1, 1 here, and this bit here is what we call an asymptote. It's a curve that gets closer and closer to a line, in this case the x-axis, but will never meet it. So we've got an asymptote here, 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 and here as a special feature of hyperbolas. Okay, this one we've got xy equals minus 3. Now if we divided both sides by x, we can get a bit more of a familiar idea about what this looks like. It's actually y equals minus 3 over x, and you've got a minus there, otherwise it's in a fairly hyperbola sort of situation. Our basic hyperbola that we saw in the last example was y equals 1 on x. So when we've got a number on top and an x on the bottom, we will have a hyperbola shape with it split into two bits. I'm wondering whether you remember what effect a minus up there has on where we draw this sketch for this hyperbola. And yes, we have it drawn in the second and fourth quadrants, and also the top number was a 3 when we wrote it as y equals minus 3 on x, or minus 3 for that matter. When you go across 1 and down, you note that it goes through the point minus 1, 3. So that top number has something to do with how close or how far away from the origin the hyperbola is drawn. You'll notice in a similar way you go across 1 and up 3 to get to there, you go up 1 and across 3 to get to there, and you go down 1 and across 3 to get to there. So this top number here kind of defines how close to the origin your hyperbola is sketched. So check out hyperbolas if you're not sure, but that's a quick rundown of what they look like. Thanks for listening. Catch you next time.